Are you tired of waiting for your terrible teammates' code to finish running?
1 hour later.
Are you frustrated with sifting through large amounts of data from existing profiling tools to find where the pattern is? Introducing your new favorite Python profiler, Looks Hot to Me. Now you can see exactly where all those performance bottlenecks are, because they'll be highlighted in bright red. You can't possibly miss it.
When thinking of ideas for a project, we thought, wouldn't it be cool to see exactly how bad each line of your code is? We then set out to find out what tools existed in this area and quickly discovered that per-line profiling is very hard. We did find this one guy though, who seemed to be on the right track, but we thought we could do better.
To prepare for our first user study, we needed a mock heat map, which we created using Excel and output data from our chosen profiler, pprofile. We gave this mock heat map to our first participant to collect feedback on our visualization prototype.
Thank you for participating in our user study. So our little task for you here is that you were writing some code for a group project, and you're relying on the abstractions that your teammate wrote. But so your main method is running slower than you would expect. So you run our Looks Hot to Me tool on it to try to see what the issue is.
It seems like it's very easy to find out where the slowdown is happening. Yeah, that's good.
Is there any more information you wish you had right now?
It might help if these were actually just different colors. So I would actually just know what I'm looking at all the time.
Alright.
Good job, guys.
Using pprofile, we designed a script that collected data that would be useful for our visualization and output it to a JSON file.
We then added multiple ways for the user to interact with our tool. Our script can be run from the command line or imported into an existing Python codebase in several different ways.
After the profiler finishes running, our script automatically opens a web app that displays the data to the user in the form of a heat map.
Once the web app is opened, you will see a list of files that were profiled. Clicking on a file will bring up the heat map for that file.
The heat map is displayed in a user-friendly manner, with an option to toggle between different views to access multiple layers of information.
For our next user study, we wanted to evaluate how much faster people could identify performance bottlenecks with our tool compared to an industry-standard profiler called cprofile.
Welcome to our user study. The task is, given this, can you identify where in this file is the performance bottleneck?
20 minutes later.
So this is our app.
Wow, this is so much easier because there's colors in here compared to like what terminal has. You know, I definitely know like where I can the problem is.
On this side is the output from the current industry standard profiler for Python, cprofile. Your job is just to identify what's running so slow. So this is what our app is now. So we took the profiler data and then launched into a web app. We have a different piece of sample code. And same problem is we're just asking you to identify which line or lines of this code that take the longest to run, where it's spending most of its time.
This is very, very simple.
Yes.
I was scrolling it and I was like, well, it all looks the same. It's just like light purple and then suddenly dark purple. And I was like, it's here.
Perfect.
It's here.
Our user study participants saved a significant amount of time using our tool. In one case, a reduction from 30 minutes using cprofiler to 7 minutes using our tool. After the study, our participants gave us valuable feedback on the other kinds of information we can provide and how we can display this information in an accessible manner. Looks hot to me. LGTM wins. Hot brutality.